Hey everyone, my name's Arjun, and welcome to my talk titled NLP for Security Log Analysis, Learning to Crawl Before You Run. So let's just start off with sort of a brief introduction to myself. I'm a detection engineer at Databricks. I've been kind of in the ML security domain for a while, and some people would call it a specialized skill. I'm having a full-blown existential crisis. That's me on the side. Not part of any of these groups. So hopefully I'll get at some point I'll be there somewhere in the middle. But yeah, that's kind of been like my whole career basically. So I thought this was an appropriate way to sort of put myself out there. So we have quite a few things on the agenda. So most of my talk is focused on embeddings. And I will talk about what embeddings are and what they sort of represent. But the idea is like, can we actually use NLP models to sort of build out embeddings and then sort of use them downstream for detection engineering tasks? So I think this particular sort of diagram or chart is like very familiar to a lot of people who work on the detection engineering side of things. You have like a bunch of data that sort of comes in, you're trying to do detection, you're trying to do correlation. And then you're sort of feeding in alerts to the sort of the IR team. Now, the idea is like this is not sort of restricted to just security. I'd feel like the idea of extracting sort of signal from noise is sort of relevant across a lot of different domains. And that's kind of what I was thinking when I was thinking about using NLP techniques. Like it shouldn't be just restricted to security. It shouldn't just be restricted to other fields. So why not security? Because the problems are the same. Security logs, I believe, are a language of their own, probably harder than a lot of other languages. And NLP, I feel like, has been specifically designed to help with context. And I do believe context is very important in security. So that's kind of where sort of things built up for me when I was sort of thinking about this and when I was working on the project associated with it as well. We'll now sort of get into the detection engineering side of things. On the left here are sort of examples of Kubernetes audit logs. I took like Kubernetes as an example because I feel like I spend a disproportionate amount of time staring at them, and they are my favorite logs, I feel like, by now. So the idea is like when I'm building out detections, like how do I go about doing it? Like I do believe like static rules are very important. So you're looking at maybe user agents, maybe you're looking at resources, looking at a bunch of different fields. The problem with these sort of logs sort of arises with the fact that schemas become very complicated. Cardinality of certain features becomes really difficult to manage. So at that point of time, you're kind of playing whack-a-mole with your static detection rules. And most of the times, if you just have those rules, you're going to miss out on something. Not to say that they're not important. So having sort of worked on sort of the ML detection side of things, I do believe that sort of there is a lot of, I would say there's a lot of advantages to using sort of a narrow approach, which is sort of associated with static rules. And then there is, you have sort of umbrella models, as I like to call it, with either you're using machine learning or you're using other techniques to sort of get like a more holistic view of your detection sort of engineering use case. Which is kind of why I have these options here. So, your option one is your static rules, then you have your embedding or other ML techniques. But the best way to sort of use them, I believe, is using a combination of all these options. So what are embeddings? And this is kind of like the core of my talk. Embeddings are nothing but numerical representations of a word or a phrase. They're widely used in pretty much every other field that has text associated with it. Recommendation systems are something that pops out that use a lot of embeddings very, very successfully. So it's basically the ability to sort of map this word or phrase, or in this case a security log, to a vector of numbers. This could mostly be in a higher dimensional space. So what it basically means is you have your audit logs, which are mostly and completely just text. You have like an embedding model, and then you end up building these features, which you can then use downstream. So embeddings are basically your core of all the other downstream tasks that you're sort of trying to build out. But what I really like to call it is it's essentially building a representation of logs. So it's trying to incorporate context as well, and which I'll talk about later. But the fact that this representation can be really powerful in terms of doing a bunch of other downstream tasks, I think that's where sort of the core of the embedding side of things sort of lie in. Just a quick pointer to like sort of this this diagram here. I wanted to take an example of like 2 different user agents. And I wanted to point them out that, if you actually sort of build out the embeddings associated with them and sort of display them on a 3-dimensional plane, you'll see that the distance between them is not just the fact that, they have different strings associated with them. Embeddings actually help you sort of differentiate between logs, which is so important when, I believe, like when you're sort of dealing with detection engineering tasks, because you're trying to you're spending a lot of time sort of trying to kind of find the needle in the haystack. So it's sort of really important to figure out methodologies that would help you do that. So I've kind of mentioned context a couple of times, and I wanted to sort of elaborate a little bit on that. On the left is a completely fake user agent. I'm pretty sure this doesn't exist. But I wanted to point out the word Linux, right? Because that's really common. As detection engineers, we spend a lot of time, building out parsing agents or writing complex regexes sort of to build out these features or detection rules. Now, the idea is that when you have this word Linux, the strings around it matter as much as Linux itself. You may have many Linux-based user agents, so how are you going to differentiate between those? So the idea is, yes, you can write a lot of regexes. You can write a lot of complex regexes as well. Or you could use something on the NLP side of things that'll help you differentiate sort of between them. The idea is like there are a lot of modern NLP techniques and models that have come up, BERT as an example for this talk, that do help sort of figure out the contextual part of it. It's called attention or self-attention in this case for BERT. And the idea is you can use these techniques to figure out like if there was another user agent with maybe like a different version name or a different string that follows Linux, the fact is that context is incorporated, and you could use embeddings to sort of differentiate between them. Or you could just keep writing regexes. That's all up to you. Welcome to the AI hype cycle of our times. I felt like I had to put this, after a conversation with my manager. And I couldn't fit in all the models. So there are like 4 of them, but a few hundred probably came in the last month as well. But the idea is, the model that I use is sort of right down at the bottom, the first one, BERT, which sort of came in 2018. Needless to say, LLMs are obviously the in thing right now, and everyone's building one. And not to say that they're not important, but I do believe that there is a lot of value in smaller models as well, especially because security is such a closed domain. Every enterprise has a certain set of logs. Every enterprise has subtle differences in the way they have their logs, and it's very hard to find a one model that beats them all in security. Unlike other use cases where you're just talking about text generation, or you're talking about chatbots, or I don't know, you're trying to make ice cream. All the other things that are associated with it, you can have one big model. But with security, I feel like because it's so constrained, and because enterprises differentiate so much from one to the other, you'll end up having to make custom models. The fact is, LLMs haven't just come in since November of 2022. They have been in use for a while now. I bring up the point of distilled models because distilled models are the models that are sort of smaller in size but have comparable performance, that have been used across the open source community for a while now. So, one of my favorite BERT models is distilled BERT, which is basically using maybe 60% of the parameters that BERT uses, or more optimized models such as Roberta as well. And they become very popular. They work really well. they're not as compute heavy. So I do feel like there is a lot of scope for using such models within security, and not just BERT models. Classical machine learning, I do believe, still has a place in security. But we live in the times where we're talking about bigger and bigger models. So I think there's something to be said there. So I'll come on to the security detection side of things. And I wanted to sort of walk everyone kind of through the process of security detection itself. I picked Kubernetes logs again because they're right now they're my favorite log source. But as you can see on the left, that they are pretty complicated. I'm not a Kubernetes expert by any stretch of imagination, but the idea is that when it's sort of providing you sort of very detailed information about whatever's sort of happening on your control plane, and that is very important for detection engineers. In most cases, whenever there are services that are sort of associated with Kubernetes, you can have a bunch of different logs, but audit logs are generally the one that people sort of walk in on and try and build out detections. They're also very useful for operationalizing things. In most cases, when you're building out these detections, it's associated with static rules, right? You'll probably end up maybe looking at the user agent. You'll try and figure out whether there are user agents that haven't sort of been part of the system for X amount of time. You'll probably end up excluding a bunch of usernames, and you'll probably reach the point where you've excluded everyone so that your rules don't generate any noise. And that can get frustrating, right? Because if you go on the other end of the spectrum, you're flooding your IR team with alerts. So while static rules can be used precisely for certain use cases, I do believe that you need something that is sort of wider or sort of a more umbrella-based approach as well. So the idea here is, we're going to be using embeddings to generate what is a representation of logs such as this. Okay, so before we just go on to the previous slide itself, I do put in step one as figure out your data, which is at a minimum understand what each of the fields mean at least. You also need to be understanding sort of how it sort of fits in within your system. When you're sort of using NLP-based techniques, I feel like the second step is kind of the most important one. So this is called the tokenization process. So you have a bunch of text, and you are converting them into a bunch of numbers. This is because neural networks do not understand anything but numbers as inputs. Now, the process of tokenizing itself can get very complicated. You could sort of build your own tokenizer, but building your own tokenizer also requires you to build your own vocabulary and then build out a tokenizer on top of that. And building out a vocabulary is difficult. There are a lot of sort of pre-built vocabularies available and pre-built tokenizers available, which you can use to sort of convert text into the tokenized values. In most cases, even with the smaller models, and I say small sort of very lightly, but a BERT model with, say, 300 million parameters, which is by comparison nothing compared to maybe ChatGPT or GPT 3.5, which is 170 billion. Training those models from scratch is hard. So, I would advise anyone who's sort of looking at text data for security and trying to build their own tokenizer, good luck. That'll take a lot of time. So I would say, use the pre-built ones, because pre-built ones have enough information within the corpus to sort of incorporate the things that you need. The third step is sort of trying to figure out your embedding model itself. Now, I have this example here as the BERT model itself. So sort of going into the specifications of the BERT model is sort of beyond the scope. But the idea of sort of these powerful NLP models is sort of twofold. You could either pre-train the models or you can fine-tune the models. Now, the pre-training part is sort of an unsupervised, semi-supervised way of sort of learning the language representation. When you're pre-training a BERT model, you are going to take like a bunch of logs, a lot of logs, and you're trying to sort of, to some degree, train the BERT model from scratch, and then you're going to fine-tune it on a specific task. In a lot of cases, and in this case as well, I used a pre-trained BERT model that was already available, that had been using the English language corpus, and then I sort of fine-tuned it on a specific task. So in this case, my task was, as you can see, there's a classifier up there, and I was trying to predict for each specific set of logs, like what the verb type is. The idea was I would take this embedding model, have it predict what the verb type is, and then sort of extract the embeddings out. Those embeddings would be my representation of the logs itself. Now, of course, like I said, you're welcome to sort of pre-train your BERT model and then fine-tune it on your own objective. But from what I've seen, there haven't been too many pre-trained cybersecurity specific models. I think maybe a couple of them, but on the other hand, if you see a lot of other fields, you'll see a lot more because it's just sort of more viable to sort of build them out. But so this is kind of like the story for now, in the sense that, I have a model, I'll be predicting the verb types, and I'll be extracting the embeddings and seeing sort of what comes out of it. And this slide sort of talks about the embedding results themselves. I have a point there about embedding, sort of evaluating your embedding results aren't the same as evaluating your model. It's sort of a little bit more ambivalent when you're trying to figure out how to evaluate your embedding results. What I did was I trained the model on approximately 7,500 K8 log samples, and they aren't that many, but you can always expand them. But my idea was to sort of take the embeddings generated by the training set and then sort of display them on a two-dimensional representation. And as you can see, sort of each particular verb type has a sort of specific spot in the cluster, which kind of shows that the embeddings were successful in sort of breaking each of these verb types into like these separate clusters. And that's kind of like an indication that, hey, you know what, like these embeddings worked. These are a representation of your logs based on your sort of your objective function. When you're training the model itself, it's sort of a more straightforward sort of multi-label classification model. So you're just going to use something sort of more traditional, like an F1 score or something of that sort. So we're going to take these embeddings and then use them downstream. So the idea is, trained on all these logs, I have a good representation of my logs, which is based on this particular plot, and now I'm going to use it downstream. Credit to the Stratus Red team, who sort of have excellent documentation on a lot of red team use cases. So I picked up one of their use cases, which is, can we detect if within a K8 cluster, if an attacker tries to dump all the secrets within the K8 cluster itself. Now, ideally, would you have a rule for it? Yes. There is a very high possibility you don't as well, because hey, that's just the way things work in the detection engineering world. Should you have RBAC control? Probably, but again, you may not have it. But the goal of this thing is, not to sort of point out who's going where on the detection engineering side of things. It's about me sort of taking this log and simulating this on my sort of test or validation data set and seeing if like my embedding model can sort of find this particular log. So that's kind of what I did. I had a bunch of validation data. I simulated the presence of this particular log. Sort of the main parts are, if you can see like the attributes and the objective resource. There are secrets, and that person is basically asking to kind of dump all the secrets and list them all. The method does become pretty relevant, because what I'm going to do is I'm going to take all the verb list types. and sort of see if I can find this particular log within sort of my embedding process. So that's kind of what I did. And as you can see, what I did was I generated like the embeddings for the verb type list for the malicious and that single benign data point. The blue data points out here indicate benign data points, and that single one gigantic orange data point indicates the log which was used to list all secrets. My hypothesis was that it would be isolated to some degree, and it does work like that. Of course, certain caveats are the fact that the model itself was trained on not too many logs, so I would say that I would have needed sort of more examples of the verb type list to have like a better representation. But the idea was that machine learning models that you're sort of using for cybersecurity are not meant to find, or sometimes are not meant to find like specific instances of this going wrong or that going wrong, right? It's supposed to be used in correlation with your detection rules, so that if you can see, even if you did not have this rule, if you had that particular set of points that was sort of more isolated, you could at least sort of be like, okay, you know what, this is isolated. This particular data point is something that we should investigate. This exercise in itself was more of a validation process where I could be like, okay, if we simulate this, will this be caught by the model? And it does. Challenges in looking ahead, I think, is pretty standard, I would think. ML is most definitely not a silver bullet to the security problem. I'm sort of a strong believer of sort of going wide and then going deep as well. And I think ML does help you sort of go very wide, but you still have like a bunch of rules that would help you sort of go deep. And then you'd have like a bunch of correlation efforts as well, which can sort of help you face that problem. Another point is an anomalous event is not always malicious. So, in the real world, the way things work, that orange data point won't be visible to you. That may or may not have been malicious. Maybe your system is okay with someone dumping all your secrets in a K8 cluster. I'm not sure about that, but maybe. Interpretability is a definite problem, especially with embeddings. But I think a lot of that sort of comes up to working with your IR team. I think a lot of cases are where we struggle to sort of give the right information to IR. So it's not so much about embeddings or numerical vector representations. It's just about answering the right questions when it comes to IR and giving them the right information to sort of operate when you're using ML models. Looking ahead, I think within security, I don't see one model sort of ruling them all anytime soon. So I'll talk to you guys next year maybe. But I do see like a lot of fine-tuned BERT models can be very useful because of just the fact that security is no different, I believe, from like any other field which is like very text-driven. So we should be sort of using BERT-based models a lot more than we actually end up doing, I think. And the third part is, of course, I work on the blue team side of things when it comes to using machine learning and security. But you should be using the right platform. You should be making sure that the packages that you use or the platform that you use is trustworthy. And I know there are a lot of talks here associated with sort of attacking AI models as well. So I do believe like that's something that should be kept under consideration as well. And lastly, shout out to my detection and response teams who sort of knowingly and unknowingly have sort of helped a lot with this talk. And questions?
So what mode of these large language models were you
Give it the
using?
mic, because
Were you training
it's
it
very
in
important, the mic, because they want to hear it. Just give it to me.
Or was it for classification? Can you go into the details more?
Yeah, DistilBERT is just trained on MLab, so I was using just a mass language model. Yeah.
And then do you compute anomalies with cosine similarity, or what's your distance metric?
I think you can do a lot of different things. Initially, I wanted to just shove an isolation forest onto it and be like, okay, you know what? We can just have a contamination and see what sort of comes out. You can use a cosine metric as well. I think that's a really good idea. You can. I generally believe like it's kind of hard to do that with clustering's great for visualization, but I don't think it can be used as an anomaly detection tool.
Correct.
So I do believe like a similarity metric like cosine will work.
Are you going to be around later?
Yeah.
Great.
Okay, let's give a round of applause for our presenter. If you have any questions, you can ask him any questions outside.